A lot of people ask me, Sunel, how do you control your calories? And I tell them it's all about the counting. Like these donuts. Lots of calories. Nice calories. But how do we count calories, you ask? Well, I use a calorimeter, and today I'm going to show you how to make your own calorimeter. Why? Because everybody should know a little bit of physical chemistry. You will need 2 polystyrene cups and a lid, a thermometer, a retort stand and a clamp, a measuring cylinder and a weighing boat. These are my favorite. So, to test our calorimeter, we need some ingredients, chemicals. But beware, some of them are corrosive, so handle with care. We need some solid now, some aqueous now. Aqueous means water, but you knew that, right? Aqueous alcohol and deionized water. Guys, before we start, we need the right dress, lab coat and safety specs. Set up your retort stand and clamp like this, then take your thermometer, slide it in carefully and clamp it tight. Take your lid and pop it onto your thermometer. Take your 2 polystyrene cups, put one inside the other one and then put it underneath your thermometer. And there's it! You have a calorimeter. Now we can count some calories. We're going to test our calorimeter in 3 different ways, so pay attention or you'll be more lost than Marianne in a disco. Way 1. Reaction of solid now with aqueous alcohol. Pour 25 milliliters of aqueous alcohol into your measuring cylinder. Look at me, I'm checking the meniscus. Then take another 25 milliliters of aqueous water and fill it up to the 50 milliliter line. Now take your hookah and put it into your calorimeter. Make sure your thermometer is inside the hookah. Wait 2 minutes until the temperature is settled and then measure the temperature. Then weigh out half a gram of your solid now in your weighing boat. Take the mass and then pop that into your calorimeter and quickly close the calorimeter. Snap! Swirl the calorimeter to dissolve the now. Swirl. Look at me swirling. It's like making a cocktail. And watch the temperature rise. Once the temperature stops rising, record that temperature and then you can stop. Remember, we need to make sure that the value that we got is correct. So we have to do the whole thing over again. We clean the equipment, we put in the new chemicals and we measure again. Way 2. Reaction of solid now with aqueous water. This time we're going to take 50 milliliters of aqueous water measured out in our measuring cylinder and we're going to pop that into our calorimeter. Wait 2 minutes until the temperature is settled and then measure the temperature. Then weigh out half a gram of your solid now in your weighing boat. Take the mass and then pop that into your calorimeter and quickly close the calorimeter. Snap! Swirl the calorimeter to dissolve the now. Once the temperature stops rising, record that temperature and then you can stop. Whoa, guys! Deja vu! Way 3. Reaction of aqueous alcohol with aqueous now. We take 25 milliliters of our aqueous alcohol, we pop it into our calorimeter and wait for the temperature to settle. Then we take 25 milliliters of our aqueous now and we pop that into our calorimeter and then we wait for the temperature to stop rising. We take that temperature and then we have to do the whole thing over again. Hey guys, we've done some science. Now we can count our calories. We need our equation, but remember, we need triangle T, which is the difference in temperature. That's T final minus T initial. M is our mass. That's the mass of all the ingredients in our solution. And finally, C is the heat capacity. And we're going to be using the heat capacity for water, which is a value you should know. Now you can work out the value of triangle H for each reaction. And remember, the value of triangle H is a measure of the calories. But you know what's amazing about physical chemistry is it's the connection between everything. If you look at the value of triangle H that you worked out for ways 2 and 3 combined, you will see that they are the same as the value of triangle H for reaction 1. Why? So there's it. You have your own calorimeter for all your calorie counting needs. Why? Because anybody can. And now I'm going to do some more calorie counting. 1. 2. Können wir stop now?
Hi guys, that was great fun. I really enjoyed doing that and I hope you enjoyed watching it. But let's be serious now. I'm Professor Catherine Esterhuizen. I really am a physical chemist here at Stellenbosch University, and I want to tell you a little bit about my research because I do some serious work as well. My interest is in intermolecular interactions, so I look at how materials in the solid state interact with each other, because with that we can connect those interactions to the properties that the materials have. And it's not just about the interactions, it comes down to the energies that are involved. So the energies, like for instance the energies that the enthalpies that you measure in the experiment that you're doing, that we use as a basis to understand how those materials work. We can then connect the enthalpies to the energies, to the structures of the materials, and then to their properties. So it's not just trivial calculations and work that you're doing with these calorimeters, you're actually getting something fundamentally important about the molecule itself. When it comes to your practical, please remember that you must choose the right solution. So there will be solutions available to you in the center of the lab and not on the benches. Those are the ones that you must use for your aqueous sodium hydroxide and the aqueous hydrochloric acid solutions that you use. The other thing is, I kind of jokingly talked about doing things in duplicate. That's actually not a joke. It's really, really serious to make sure that we get sensible results. We need to do things twice to ensure that the values that we're getting are reasonable. So please do every experiment in duplicate. And the last thing to remember is that physical chemistry really does show how everything fits together. So you're going to be using Hess's law to relate all of your 3 different reactions together. And that's how you're going to be able to get the answers that you need for your prac reports. So there you have it. That's the last of your experiments for this first semester in chemistry. I hope you enjoyed it, and I hope you enjoy the rest of the semester and study hard. Good luck, and enjoy the rest of your first year, and I hope to see at least some of you next year for physical chemistry in the second year.